Alright, so we're recording. Let me get this out of the way. And what you're looking at right now is the first glimpse of the UI for the Rust library that I've made. So what you can see here is we have our active runtime at the top. We have our forge, which will be right here, and our reinforcement dojo, which will be right here as well. Here you can see we have our live telemetry. It tells you your system RAM. Right now I'm running a model, so you can see the GeForce card is registered. You can see the model and the RAM that's being used there. The second card is not in use. We have the Cartridge Bay, which is where you would load your models. You can see here we have a model running. I'll go ahead and kill that model right now. So we can go ahead, let it chill out. And we also have here, so you select your model here. Right, this lists every model MDO file you have in your folder. And then from here you can select either the tiered waterfall, which fills up your VRAM first, then defaults to using the RAM and the SSD. You can do the pure RAM, which is essentially what it means, just uses your RAM. Or you can use the direct NVMe streaming, and that allows you to run pretty much any size model you can fit on your hard drive as an AI on your local machine. So here you can select which GPU. So if you're using the tiered, this is really the only one that uses the GPU, then you can select that, which GPU you want the model to run on. And just to show you guys here, I'm not going to log it, but I am going to start in dream mode. This you can actually put in your own little question if you want it to dream about something. There's some interesting stuff here. So we use the MICT protocol, and it'll format it based on your question, or you can put your own question here and have it dream on its own stuff. So right now I'm going to go ahead and start one in dream mode, and this is a Gemma 2B. We'll go ahead and get that one started. So while that Gemma 2B is starting, I'm going to go ahead and just for fun and quick demo, we'll do the tiny model here. And we'll just, just for fun, we'll put it on the direct for NVMe. So it's not actually using a GPU at all, it's just streaming from the hard drive. Let me hit that. You see you get a second window pops up here. And I get really tricky like I was showing you all earlier. I'm not going to do the 72 yet because that one takes a lot. And I'll do a tiered waterfall running off GPU 1. So now we have two models running on the GPUs, one model running directly off of the hard drive, off the SSD. So it'll take a minute for these other two to initialize. If you want to kill a model, there's a kill button up here, right? And you can run as many models here as you have resources to run. So additionally, down here at the bottom, you'll see they have these little check boxes for Dream. So you can check and uncheck that. If you want to change the question that they're thinking about, you click the config button here, and that'll stop them, and you can put a new question, start up a new question for their dream state, or you can stop their dream state altogether, right? So I can demonstrate that for you here. We click stop, system halts, click config, and you can change the dream seed, right? You can even select to log the output or select MICT again. You can close that down. So this is neat because we get 3 models that you can run, but since we're able to run multiple multi-billion parameter models, we have another neat little method here called dual brain, which if you come over to this side in the Cartridge Bay, you select dual brain, you can select one that does the initial generation and one that does a corrective generation for that. So in this case, I'll select TinyLlama because it works quick, and then I'll select, say, like the 7B Gemma to follow it up, right? I'm going to run this one from tier GPU 1 because it's small, and my GPU 1 is a little slow. And then I'll run this one tiered from GPU 0. I'm going to start them both in dream mode, right? So one is going to start with the other, and you can see here we have the hydrate, everything right there, and we'll just go ahead and click this. And so now it's going to initialize both models, one on each GPU. And what you're going to see next is once they start initializing, you'll see the VRAM being used here because of the tiered approach that I'm using. Again, that goes VRAM, RAM, and then SSD. So both of these are going to run essentially at the fastest they can run while using the same machine. So it takes it a minute here to get initialized, but because of 7B, the 7B takes a couple minutes to get going here. Boy, it is late. I am tired. So once it gets kicked up here, you'll see. That was pretty cool. Because TinyLlama 7 or 1.1b does hallucinate, like it tends to hallucinate. So it just puts all kinds of crazy words and stuff in, and the 7B Gemma actually is pretty decent. So it does pretty good job at reading and then correcting the TinyLlama. So see here, it looks like they're getting kicked up. I'm watching them on BTOP on my other screen. I can actually, you can see them all getting started and processing. So looks like the smaller one is ready. I'll wait for the big one. There we go. Yeah, there we go. So you can see, so the gray is the 1.1 billion parameter model, and the green is the correction from the 7 billion parameter model. So it's taking in this input, it's checking it out, it's comparing it, it's saying, no, you're stupid, this is the right word. So it's not actually saying that to the model. It's just like, no, that's the wrong word, this is the right word. So why you would do this is because if your first model comes up with a word that is correct, then you actually get your generation cheaper than if the bigger model was to be the one creating all the words. So you get it process wise, resource wise, you're getting more tokens for less resources. So even though you're running two models, so it's kind of interesting. Yeah, so that is the first view of our, I guess, our Ulshe AI full Rust library. So, and the UI for it.